So this is AP Calculus for response question from 2019, and it's problem number 1. So I have my calculator ready right here. And let's go ahead and get started. The fish enter a lake at a rate modeled by the function e given by, and first thing I'm noticing on this problem is that fish are going into a lake, and that's why I call these problems in and out problems. Because we have some sort of rate either going in or going out, or in this case, I think we have both going on. So this is fish that are entering. I like to write a little note for myself, but they did nicely label it E of t. And fish leaving the lake at a rate modeled by the function. And here we have leaving the lake. Leaving. A lot of times they won't label them nicely, and so I'll forget which one, or I don't want to accidentally on a problem grab the wrong function and make a small mistake that I didn't catch. Okay, so both E and T, E and L are measured in fish per hour, and T is measured in hours since midnight. Okay, and they're both rates. This is the rate of fish, and that's the rate of fish entering and leaving. So first question: how many fish enter the lake over a 5-hour period from? And this is kind of nice. They're actually giving me the t values from t is 0 to t is 5. Give your answer to the nearest whole number. All right, so we're going to use a calculator on this, but first I'm going to go ahead and set it up. This is the rate of fish entering, so what I want to do is integrate that to find the actual number of fish entering. From 0 to 5, and E of t dt. Okay, so from here, I'm going to go ahead and graph it. So let me make sure that my calculator is in radians, and it is. And then I want to go ahead and carefully enter this. So I have 20 plus 15 sine alpha f1 is pi x over 6. Close the parenthesis. And I'm going to hit zoom 6 just so it graphs it on a nice window. And waiting for it to graph. Sometimes it's easier if you have the option. I think alpha f2, you can just integrate straight from there. But I have a feeling I'm going to want to look at both of these graphs, so I'm going to graph it anyways. Now I'm going second calc, and I want to integrate from and 0 to 5. 0 to 5. That's going to shade it in for me. And I'm going to say the answer is 153.457 fish, which then I'm going to say 153 fish. 153 fish enter the lake in those 5 hours. Okay? All right, part B. What is the average number of fish that leave the lake per hour over the 5-hour period? All right, so this is a similar kind of thing. Instead of looking at E of t, we are going to use L of t. And so to find the average number of fish that leave the lake per hour, we're going to go ahead and integrate L of t dt over the same time from 0 to 5. But they want the average, so we're going to add up all of those fish that I just wrote down here from 0 to 5, L of t, add up all those fish, and then I want to divide it by the interval. Okay, so same kind of thing, similar kind of thing. I'll show you how to enter it the other way now. So I think alpha f2, if you have this shortcut, and then you can go to, I believe this is it, right? Yep. From 0 to 5, and it's going to be L of t, which is right up here. So it's going to be 4 plus 2 to the 0.1 x squared. That's not squared. Squared. Good. And an x goes in that spot. And the only thing I haven't entered is divide by 5. So final answer is equal to 6.059. And they didn't ask me to round to number of fish because this is just the average number of fish. And remember that you want to write both things. You want to have this guy because this is going to be worth probably 1 point. And then you also want the answer to 3 decimal places because that's going to be worth a point as well. So hopefully at this point, I'm guessing 1, 2, 3, 4 points hopefully. Okay. All right, part C. At what time t from 0 to 8 is the greatest number of fish in the lake? Justify your answer. All right, so this is a problem where you want to go ahead and set up a little chart. We've done problems like this before. We want we always want the end values, right? The end points. We're looking for critical values. So 0 and 8, and then anywhere along the way that we want to look. So I think what I want to do is I want to go back to my graph, and I could see where they crisscross. I could also just say this is the number of fish that are entering, and then I want to take away the rate. I want basically the derivative to equal 0, right? And we already have derivatives. This is one of the derivatives, one of the rate of changes, and then minus the other one. And I'm going to put this all in parentheses. 4 plus 2, this is just the other function, to the, and then 0.1 x to the second, That all looks good. Did I get everything? I think I did. Let me move over, close the parenthesis, and then regraph it. All right, so from 0 to 8, I'm looking for when this thing is going to equal 0, and hopefully it is. Like I said, this is the derivative, so right there it equals 0, but that's not in my range, or domain that I'm looking for. Is it going to cross somewhere right over here? Yep, that's the value that I'm looking for, okay? And it's going from positive to 0 to negative, so this is a potential maximum, and that was greatest number of fish. This is one of the values that I definitely want to look at. Okay, so I'm going to go second calc, and then I'm going to find that 0. Left bound, so I'm scrolling to the right. Left bound, there it is. Left bound, right bound, and then enter. And so it looks like 6.203. 6.203. So the question is, which one of these is the actual maximum, right? Is it that guy, this one, or that one? So this is the number of fish that are there. And I know at 0, it's going to be, well, 0, they didn't give me an initial condition, so I'm just going to assume 0 is 0. The next one, 8. Do I know that value? 8. I guess I'm going to have to integrate this thing. And if I integrate from 0 to 8, second calc, integrate from 0 to 8. Let's see how many fish are in that section. Because this is both fish going in and out of the thing. So it looks like, yeah, so this is fish coming in, that's fish going out. That means we're taking away. So the other answer is definitely going to be the maximum. That answer was 80.919. Let's write that down. 80.919, and this is definitely going to be the maximum. I could see that the most area is being added there, and then this is negative fish, right, or fish leaving. So let me get that last answer, second calc, and then I need to integrate from 0 to 6.203. I don't actually need the number of fish, I just wanted this answer on there so I could show that it was actually a maximum. Right now it's shading behind the scenes. So this is the answer that I'm looking for, and it's going to be 135.014, even though you can't have a portion of a fish. That's right there. Okay? All right, so let's make sure we actually answer the question. At what time is the number of fish just, okay, so at time equals 6.203 hours. The fish is at a maximum. And my justification is right there. Okay. All right, last one. Is the rate of change in the number of fish in the lake increasing or decreasing at time 5? Okay, at 5 hours, 5 a.m. Explain your reasoning. So this one I'm thinking about for a couple moments, because it's asking, is the rate of change increasing or decreasing? Which is kind of a way, it's not asking is the rate of change positive or negative, right? Because then I would just see if there are more fish in or more fish out. It's asking if the rate of change is increasing or decreasing. So I think instead of just looking at E and L, what I want to do is I want to go E prime of T, and then I want to take away the number of fish leaving, L prime of T. The prime should be right there. But I want to look at the rate of change. The rate of change is rate of change. So basically this is an acceleration problem. Since I already had the first derivative right here, now I want to take the second derivative. If it said, is the rate of change positive or negative, right? Positive would mean more fish are going into the lake, and then negative would mean more fish are leaving the lake. It's not asking that. It's not asking positive or negative. It's asking, are they increasing or decreasing? And luckily, I already have this graphed, right? That's already there, so that's why you really, really want to be careful typing it in. And now, with my graph, I just want to take the derivative. So second calc, and I'm going to scroll down to derivative at 5. Derivative at 5 is, and on this calculator, I see the 17 pop up real quick, but this is the actual derivative. It's going to be negative 10 at 5. Let me, in a different color, put a 5 in there. That's the moment we're looking at. And we got negative 10.722. And the 10.722 doesn't really matter. It's the fact that it's negative means that this thing is concave down, means that it is decreasing. So I have to actually justify that. I'm going to say decreasing because I'm going to say E prime of 5 minus L prime of 5 is negative. Okay, and I like to box up my actual answer with the rest of the description or rest of the explanation just hanging on there. So hopefully this problem is pretty straightforward for you. Has a couple things going on. Like I said, in and out problems, sometimes they just have fish entering, and that's what the whole problem is. Sometimes they just are talking about something going down. You might see one of those. Or sometimes it has in and out where it's entering and leaving or going up and going down. Okay?